Today I'll be going over Chapter 10, which is Counting Methods and Probability. 10.1 is Apply the Counting Principles and Permutations. So, for example, here's a tree diagram. At Boba Ave, you can choose between 4 types of teas: black tea, green tea, black milk tea, and green milk tea. 2 types of ice levels. I'm going to write no and L for no ice and light ice, and 2 types of toppings: black sugar boba and lychee jelly. And we want to create a tree diagram to find the number of possible combinations. So there's 4 different types of teas we can choose from. So there's black tea, green tea, black milk tea, and green milk tea. And after you choose a drink, we have 2 ice options. So from each drink, you have 2 choices, either no ice or light ice. And after you choose the ice levels, you're going to choose the toppings. So you can choose either boba or lychee jelly. And after you complete the tree, you can count the numbers of options at the end. So it's going to be the last branch here. And that's 16. So there's 16 combinations. Okay, next is the fundamental counting principle. So for 2 events, if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. And for 3 or more events, if 3 events can occur in m, n, and p ways, then the number of ways that all 3 events can occur is m times n times p. So if we go back to the first example, we have 4 options for the tea, and 2 options for the ice, and 2 options for toppings. So if we multiply 4 times 2 times 2, that's 16, and that's another way to get the 16 combinations. So in number 2, at Potato Corner, you can choose between 3 different styles of fries, 3 different sizes of fries, 5 different styles of fries, and 6 different flavors. So if we multiply all of that, we'll get 90, and there's going to be 90 combinations. Okay, here we have permutation, which is an ordering of n objects. Factorial has a symbol which looks like an exclamation point. So 4 factorial is 4 times 3 times 2 times 1. So you're just going to multiply all the numbers in decreasing order until you reach 1. And for permutations of n objects taken r at a time, npr is n factorial over n minus r factorial. So for the given configuration, determine how many different license plates are possible if A, digits and letters can be repeated, and B, digits and letters cannot be repeated. So for number 3, we have 5 digits. So I'm going to draw 5 blanks and just draw a number sign so I remember that these are all for numbers. And then 3 letters. So that'll be 3 spaces with L. So for the number of possible choices we have for digits, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So these are the numbers that we can fill in for a digit. And there are 10 choices. So for the digits, there are 10 choices, and since we're allowed to repeat, all of the digits have 10 choices. Then for the letters, there are 26 letters in the alphabet, so we have 26 choices for each letter. And if we multiply this, we'll get 1,757,600,000. And that's the number of different combinations if we're allowed to repeat numbers and letters. part B is when we're not allowed to repeat. So we still have the same setup. We have 5 numbers and 3 letters. So for the first digit, we have 10 choices, but after that, we have 9 because we already used a digit, so we cannot repeat that digit. And after that will be 8, 7, and 6. And for the letters, we start with 26 choices, and after we choose a letter, we cannot repeat it, so we have 25 and 24. And once we multiply that, that will be 471,744,000. So those are the number of combinations there are. For number 6, we have 6 letters. So for part A, this is where we're allowed to repeat. So all of these are letters. And there are 26 letters we can choose from. So for all of them, it's going to be 26. So you can type in 26 to the 6th power on your calculator. That'll be 308,915,776. And for part B, this is where we're not allowed to repeat. So for the first letter, we have 26 choices. After we choose a letter for the first spot, we only have 25, then 24, 23, 22, and 21. And that'll be 165,765,600. Okay, next we're going to be evaluating factorials. So again, factorials are the exclamation point that you see. So 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you're starting at the number in front of the factorial and then going down all the way to 1. And if you multiply this out, you'll get 479,001,600. Number 6, we have 3 factorial times 4 factorial. So 3 factorial is 3 times 2 times 1, and 4 factorial is 4 times 3 times 2 times 1. And once you multiply this, you'll get 144. For number 7, we have 8 factorial over 8 minus 5 factorial. So first you'll want to simplify the denominator. So 8 minus 5 is 3 factorial. And we can write out 8 factorial as 8 times 7 times 5 times, 6 times 5 times 4 times 3 factorial. And we can stop there because it'll cancel out with the 3 factorial in the denominator. So we're multiplying 8 times 7 times 6 times 5 times 4, and that's going to be 6,720. Okay, next we're finding the number of permutations, so we're going to plug this into NPR, which is n factorial over n minus r factorial. So for number 8, we have 10p1, so that's going to be 10 factorial over 10 minus 1 factorial. 10 minus 1 is 9, so we have 10 factorial over 9 factorial. So when we write out 10 factorial, we can stop at 9 because that'll cancel out with the 9 factorial in the denominator. And that'll equal 10. For number 9, we have 13p8. So that's going to be 13 factorial over 13 minus 8 factorial. 13 minus 8 is 5. So that's going to be 13, 12, 11, 10, 9, 8, 7, 6, 5 factorial. And we're going to stop at 5 factorial because that's where it can cancel out with the denominator. So we're multiplying 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6, and you'll get 51,891,840. For number 10, we have 15p0. So that'll be 15 factorial over 15 minus 0 factorial. 15 minus 0 is 15, and this will simplify to 1. Okay, permutations with repetition. The number of distinguishable permutations of n objects for one object is repeated s1 times, another is repeated s2 times, and so on, is n factorial over s1 factorial times s2 factorial all the way to sk. So n is the number of letters in the word, and s is the number of times a letter is repeated. So in the word tree, there are 4 letters, so we're going to have 4 factorial on the top. And the letter E is repeated twice. So we're going to have 2 factorial in the denominator. So when we write out 4 factorial, we can stop at 2 because that can cancel out with the 2 factorial in the denominator. And we get 4 times 3, which is 12. For number 12, we have the word yellow that has 6 letters in it. So we have 6 factorial in the numerator. The letter L is repeated twice, so we have 2 factorial in the denominator. So when we write out 6 factorial, we're going to write it out until 2, because that's where it can cancel out with the denominator. So we're multiplying 6 times 5 times 4 times 3, and that is 51,800,000, oh, oops, sorry, just kidding, 360. Okay, last one of these words, we have the word Mississippi that has 11 letters, and there are a couple letters that get repeated. So I is repeated 4 times, S is repeated 4 times, and P is repeated twice. So all of these numbers I'm going to write in the denominator. So we have 4 factorial, and 2 factorial. So when I write out 11 factorial, I can only cancel out with one of the factorials in the denominator. So I'm going to write it out to 4. Because that'll cancel out with the first 4 factorial. And after that's canceled out, I won't have any factorials in the numerator to cancel out anymore, so we have to write out 4 factorial as 4 times 3 times 2 times 1, and 2 factorial as 2 times 1. But now it's a multiplication and division problem, so we can see if we can simplify anything. So 4 times 2 in the denominator will equal 8, so that'll cancel out with the 8 in the numerator. And 3 times 2 in the denominator will multiply to 6, and that'll cancel out the 6 in the numerator. So we're really multiplying 11 times 10 times 9 times 7 times 5. And we'll get 34,650. Okay, next we have, or we're solving for n. We have np4 equals 8 times np3. So np4 is n factorial over n minus 4 factorial. So I'm just using the permutation equation. And np3 would be n factorial over n minus 3 factorial. So now we have to write it out and try to cancel. So since we don't know what n is, we know that the next number is going to be n minus 1, and the one after is going to be n minus 2, and so on. And I want to stop at n minus 4 because that's where I can cancel out with the denominator. And for n factorial over n minus 3 factorial, I want to multiply out n factorial to n times n minus 1 times n minus 2 times n minus 3. And I can stop here because it'll cancel out with the n minus 3 factorial in the denominator. So this part will cancel out and this part will cancel out. So we're left with n times n minus 1 times n minus 2 times n minus 3 equals 8 times n minus 1 times n minus 2. And since we're multiplying everything, if you see something on both sides of the equation, we can cancel it out because we could divide both sides by that part. So both sides have n, and we could divide both sides by n, and that'll cancel n. Same with n minus 1, and same with n minus 2. So we're left with n minus 3 equals 8. And then to solve for n, we're going to add 3. and we get n equals 11. For number 15, we have np5 equals 9 times np4. So np5 is n factorial over n minus 5 factorial. And 9 is n factorial over n minus 4 factorial. Or np4 is n factorial over n minus 4. So now we want to write out the numerator n factorial. So that'll be n times n minus 1 times n minus 2 times n minus 3 times n minus 4. And I'm going to stop at n minus 5 factorial because that's where it'll cancel out with the denominator. And for n factorial over n minus 4 factorial, when I write out the numerator, I want to stop at n minus 4 factorial because that's where it'll cancel out with the denominator. Okay, so this will cancel out and this will cancel out. And we're left with n times n minus 1 times n minus 2 times n minus 3 times n minus 4 equals 9 times n minus 1 times n minus 2 times n minus 3. So again, we can cancel out whatever we see on both sides. So we can cancel out n minus 1, n minus 2, and n minus 3. So we're left with n minus 4 equals 9, and to solve for n, we're going to add 4 to both sides. So we get n equals 13. Okay, number 16, a photographer lines up the 15 members of a family in a single line to take a picture. How many different ways can the photographer arrange the family members? So there's 15 spots. And we can figure out how many different choices we have for each spot. So in the first spot on the left, there are 15 choices because no one is placed yet. But after that person is placed, we have 14 choices for the second spot, 13, and so on, until we have one person left for the last spot. So you can fill in all the numbers and multiply it, or you can use 15 factorial, and you'll get 1.308 times 10 to the 12th. So this is the number of different ways you can rearrange the 15 people. A Spanish club is electing president, vice president, and secretary. The club has 9 members. How many different ways can the 3 positions be filled? So we have 3 spots. In the first spot, there are 9 people we can choose from, but the president cannot be a president and a vice president or a secretary. So after we choose the president, there's only 8 people left that we can choose from for vice president. And once we pick the president and the vice president, there's only 7 people left we have to choose for the secretary. So if we multiply that, that will be 504. And another way we could do this is with permutations. So we have 9 people and we're picking 3 of them. So 9p3 will also be 504.